Hello, welcome to today's webinar on Oracle E-Business Suite Account Password Decryption Threat Explored. My name is Phil Ryman. I'm the Director of Business Development at Integrigy, and I'll be the moderator for this e-learning session. We have two speakers today. One is Stephen Kost, who's the Chief Technology Officer of Integrigy Corporation, and the other is Jeffrey Hare, who is the founder and CEO of ERP Risk Advisors. And I'll turn it over to them and let them introduce themselves further.
Great, thanks, Phil. This is Jeffrey Hare. I'd like to extend my welcome to everybody on today's call. This is the last in this series of webinars that Steve and I are doing together that is exploring a wide variety of risks, more within the IT security element or IT security realm, featuring a lot of the domain expertise that Steve has been bringing in the public domain. I'm excited to be here today. For those that don't know, I'm a CPA by trade and have 14 years experience in the EBS space as client consultant. We specialize in security controls, and we are kind of the application security experts. Steve kind of handles all the elements below the application level. So we were pleased to present this series and pleased to present this particular topic. We find that a lot of companies are still struggling with this issue, even though that Oracle has provided a fix, that the fix hasn't been implemented in a lot of organizations. So Steve's going to do a great job today at presenting this information and taking the topic and demonstrating it along with it. So I'm going to turn the call over to Steve.
Thanks, Jeff. My name is Steve Kost. I'm the CTO and founder of Integrigy, and I've been working with Oracle E-Business Suite for the last 14 years, focused on security. So my background is more on the technical side, very much on the IT security. I've also been an apps DBA, so I very much understand how to run Oracle E-Business Suite and keep it up and running. So kind of complementary to Jeff, who does more on the application control side. Integrigy focuses on the IT security side of E-Business Suite. For those of you not familiar with Integrigy, we basically specialize in Oracle E-Business Suite security and Oracle database and Microsoft SQL Server security. And we both have a product side and services, and a lot of the work today and the presentation today is out of our services work. So when we do on-site security assessments, we kind of learn a lot about how the customers are running Oracle E-Business Suite, some of the things that they're missing. So this presentation is based off of about 80% of our security assessments in the last 2 years identified this issue as a key concern for our clients. And so a lot of people are not doing this. Only about 20% of the people are actually fixing this issue that we're going to talk about today. So before I get started, I wanted to first kind of talk about the exact topic. So when we talk about account password decryption, we're talking about the Oracle E-Business Suite application user accounts. So these are basically the end users who are signing into the E-Business Suite. They all should have passwords when they sign in, and those are being stored in the E-Business Suite. When I talk about encryption and decryption, just to make sure we level set, when you encrypt something, basically you're taking a key and basically making it unreadable unless you have the key, and you can then decrypt it. And so basically the threat here is that the passwords by default in the Oracle E-Business Suite are stored encrypted, and then people can go in and actually decrypt them. And then we'll also talk about another term called hashing. So hashing is a little different than encryption. Encryption basically is reversible. You can basically take something encrypted and get the information back. Hashing is basically you take that information and you apply an algorithm to it, and the only way you can ever check if that's right is you take the original information, hash it again, and see if the two hash values are equal. We'll talk about hashing is because that's how Oracle's actually fixed this problem. So kind of let's get started and discuss what a typical threat for this is. So again, we're talking about the application user passwords are stored in Oracle E-Business Suite. And so typically what's happening is during a typical E-Business Suite implementation is you're actually doing cloning. So once you've gone into production, you're taking the production environment, so number one here in the flow, and actually cloning it to test and development on a periodic basis. When you're doing that, you're actually taking all the data from production and cloning it to test and development. So your test and development databases are pretty similar and have most of the data that's in production. Hopefully you're at least scrambling sensitive data like credit card numbers, social security numbers, things like that. One of the things that people often miss is when you're doing the cloning, you're also taking all the users' passwords from production and putting it into test and development. So then what we do is let's take an example here is our threat will be one of the programmers. This programmer may be one of our offshore programmers maybe our contractor. We might be terminating his contract coming up pretty soon, so he's kind of a little disgruntled. And so what he can actually do is then, since we've already cloned all the data to test and development, he doesn't have direct access to production, but he has access to maybe a development environment. He can actually go in and take the information, because you provided him access to development, because he actually has to develop. He might even have the apps account in the development environment, or he has potentially just a read account. But he has to basically be able to create PL SQL packages and do things in the environment to basically test his programs. So then what he can do is actually go through and take all the application passwords and decrypt them. So he has enough information in the test and development environment to actually go through and using some simple SQL statements that he basically Googled. So if you Google Oracle Applications Password Decryption, there's 50 sites out there that have detailed instructions, so it wasn't anything that he even had to make up or spend much time on. And he can actually then decrypt all the end user's passwords. So now he's got basically your CFO's password, all your accounts payable, clerks and managers and super users' passwords, and now he can actually just log into production with all those passwords and basically do anything he wants. So this would be a classic procure-to-pay fraud. So he can basically create vendors and do a lot of different things. And since he's got every user's password, if he has a little bit of understanding in the process, he can probably just go through and actually approve all those workflows and do everything that a normal process would require 3 or 4 people, have sufficient application controls. But since he's basically one person with access to maybe a dozen different users, he can actually circumvent all your application controls. So even though you've done segregation of duties perfectly, you've spent a lot of time making sure the application controls are secure, one person can very easily go in and get all this information in production. This is very much an internal threat. We don't see this as much of an external threat. Someone from China is not going to hack into your environment and try to do this and get very far. But a programmer, an analyst, anybody internally will be able to very easily do this, especially because you've already probably granted them enough access to do this. So how does this work in detail? So when we start talking about the passwords, well, the passwords for Oracle Business Suite are stored in the FND user table under the Apple Sys schema. And there's actually 2 columns within that table, encrypted foundation password and encrypted user password. So every single user in eBusiness Suite will have an account. And then the 2 columns are basically, and this is really a throwover from client server days, and that's kind of the way this was designed to allow, if everyone on the call remembers 10.6 Smart Client and things like that, this is really what that was used for. In Release 12, there's really no need to ever have this type of design, and when Oracle's fixed this, they've kind of removed parts of it. So basically, encrypted foundation password is the app's password, and the encryption key is a username and user password concatenated together. The encrypted user password is basically the end user's password encrypted using the app's password. And the reason they did the app's password is when you used to be able to connect with Smart Client and Client Server model, and this is the way even ADI worked until recently in 11i, you basically had to connect, and then you made a database connection using the apps account. You'd need the apps password to make that connection, and this is kind of the mechanism that they provided to allow that to happen. In R12 and beyond, there's no client-server application, so that's actually not even needed anymore, and that's why the fix, when we'll talk about later, removes the encrypted foundation password. But the key here is these are encrypted values, so I can basically, if I have the key, and the key for encrypted foundation password is the user name and the user password, and I can get back the apps password. So every single user has the apps password stored associated with their user ID, but it's using a different key. And then every single user's password is stored using the apps password. So now as we kind of go to the next step, so how do I need to actually do this? So if you really want to do this, all you have to do is go to Google and type in Oracle Applications Password Decryption, and a lot of people have got a lot of different variations on how to do these different steps. Basically, I just copied some code directly off a blog after I did a couple Google searches. I made a couple changes to make it a little bit more readable, but basically this is purely code copied. And so basically the way this works is if you want to get the apps password, you need to get the guest. The good way to do it is start with the guest user, because you know the guest is always there, and you know that it's basically got a nice, good username password combination. So in red there, I've got the function to actually call to get the guest user, and R12. And 11i is actually stored in a profile option, so you have a little different call there for 11i. But again, this is all documented well on 30, 50 different blogs, just a Google search away. The one issue here is there is a decrypt function. You have to somehow get access to the decrypt function, and I'll show you how to do that in a second. But basically, this is the SQL statement. It's a little bit more complicated because it's just going out and getting the guest user password, figuring out what the guest user password name is. Typically in the where clause at the bottom, you could just take that all out and just actually say where username equals guest would work also. So that would be able to get the app's password. So once you've got the app's password, what do you need to do? Well, this is the statement to actually decrypt, and I'll actually run it for you and show how it works, all the end user's passwords. So basically, I'm just putting in the app's password, and again, I need the decrypt function, and I'll show you how to get access to that. And basically now I can go through and decrypt every single user's password. This works easiest if you have access to the apps account, but if you don't, there's actually dozens of ways to do this. I'll demonstrate if you actually have access to the apps account how easy it is, but there's other ways to do it. So the one issue I talked about was basically you need access to the decrypt function. So Oracle actually has the decrypt function is a Java class. It's standard across every single Oracle E-Business Suite version and database. So all you need to do is go into one single environment and actually pull it out, and you've got the Java class that can be used over and over and over. And it's actually both loaded in the common top Java class files, and it's also actually loaded in as a Java class within the database. And our example here will be using the Java class that's actually loaded in the database. These are a lot of details to actually exploit. You don't really need to know all the exact details. I'm kind of going through the explanation so everyone can clearly understand what's happening. But basically, if you just copy the code from the internet, it works perfectly. You don't really have to understand what each line does. But here in the example we're using, and most of the examples on the internet do it this way, is they use the Java class that's in the database. Fortunately, there's not any packages in the Oracle database that expose this decrypt package by default. So all you have to do is actually expose it by actually putting a wrapper around the Java class to allow it to be called. This is very standard Oracle when you run Java in the database. This is how you do it. You always have to create this PL SQL publishing wrapper class to allow access to a Java class. So if you actually look in any Oracle Java book, it clearly explains how to do this step. Other ways you can do this is actually take out the Java class and create a little Java program offline and actually feed in the passwords just download them in a text file, and then actually have your Java program decrypt, read them from the text file, and then decrypt them there by calling the Java class that you actually downloaded from the Oracle installation on any server. So basically, that's all you have to do. And so basically, I'll kind of jump out here, and we'll actually give a little bit of a demonstration and kind of show you how easy this is to do in real life. So I've got an Oracle Vision instance. It's running release 12.1. So basically, this is standard Oracle E-Business Suite environment. I'm running in SQL Developer here. So hopefully everyone can read that text. What I'll do, and make it bigger earlier. I apologize for that. If I can figure out where to make it bigger, there it is. Make it a little bit bigger for everyone so they can see it a little bit easier. Perfect. So basically, this is the function that I'll actually create called decrypt. And all this is doing is actually creating a wrapper around the Java class. Again, this is the method to do it if you have actually direct access to the apps account. So basically, I'll just go create this wrapper here. And so the code is already there. Oracle has already provided it. And all I have to do is actually create a wrapper around that code. So actually, it's created. So now it's compiled. So now I'll go in. And so actually, if we go through, and I'll first show you the example here. Is the first function I'll run is actually going and just getting the guest account password. So in this environment, guest and the password is Oracle. So this is just one of the functions that Oracle provides. Very easy to do if you're running this as apps. The second one I'll show you is what's actually in the FND user table here. So as we kind of run this statement, this is just querying basically purely the Oracle F&D user table, and you'll see the two columns here. I'll kind of shrink them down so you can see them a little bit better, because they are pretty long columns. And so again, each user account has two encrypted passwords, the encrypted foundation password and then the encrypted user password. And the encrypted foundation password, again, is the app's password using the username and password. And then the encrypted user password is the user's password encrypted using the app's account. And we'll go after both of these just to get all the information we need. In this case, you see the ZH at the beginning of each password. The Z, G, and ZH indicate that it's the encrypted. The Z indicates that. And G and H indicate if it's actually a case-sensitive password or a case-insensitive password. So if you've got the profile option, sign-on case-sensitive, set on or off, these different passwords will either be case-sensitive or not case-sensitive. And that's how Oracle determines when they check the password to see if they should be checking it case-sensitive or case-insensitive. So that's basically what's in the user table. So now we'll kind of go through. And here's an example that now I've got my decrypt function. We'll do it a really simple way. Is I'll just take one of my user passwords instead of just taking one of these. And basically now I know the password in this environment is apps for apps. Now we'll actually run that just to kind of show you how simple it works. So I'm just taking one user's password using the apps account, and now I've actually decrypted their password as welcome456. To make it a little bit more complicated, if I want to actually go get the apps password, the statement's a little bit longer, but again, I can cut out the bottom part here and just say where username equals guest. This is a little bit more robust because it actually checks what the guest user account name is. And again, I'm just putting in my decrypt function, and I can actually now go just get the apps password. And there, in this case, the apps password is apps. So basically, I've now gotten the apps password, and in this case, all I had to use was the guest account. This works with any eBusiness Suite account. So even if I can't get the guest account, but I only know my username and password in production, maybe let's say, I can still get it because it just has to be any valid combination of username and password. This is one example also why we recommend people change every single Oracle eBusiness Suite password, even the default accounts. Even if you lock the default accounts, there's like accounts like OP sysadmin, seeded account by Oracle, they give you a default password. A lot of people just end date that account versus also changing the password. This is one reason why we actually recommend people change those passwords, just because any valid combination works here. So now that we've done the apps account, I know what the apps password here is, so we'll put it in. And now I'll actually just go in and we'll actually decrypt every user password. So this is how easy it is. Once I get access to that decrypt function, and there's other ways to do this. I'm just doing it as the apps account. It's a very straightforward, very easy to do method, and probably it's one of the simpler methods because a lot of people can go into a development environment as the apps account. Every developer can also do this because if they're writing any concurrent manager programs, they have the ability to echo out the apps password. So they can always get the apps password in a development environment pretty easily if you have development privileges. So again, here is the username and the decrypted password for this environment. This is a Vision environment, so almost everyone's password is welcome. As you can see, there's a couple that are Oracle, and a couple here are case sensitive. So when I talked about the Z and the ZH and ZG, in this case, this one user's password, Fin17, is case sensitive, and you can see how the encrypted password is a ZH, which is an indicator. The H indicates that it's a case sensitive password, where the G's are case insensitive. And that's how easy it is to do. So basically, I've gone through, and now it's gone through the Vision environment. If you want to figure out what all the passwords for all the users are in Vision, this is a very easy way to do it. As you can see, we'll kind of go through and look at them all. In some cases, there'll be a couple invalid, so the AS admin account has an invalid. But that's basically the process that you go through to decrypt the passwords. And there's other different ways to do it, but basically that is the most straightforward way that allows you to actually go through and decrypt the passwords. So kind of just to rehash where we are. So basically by default, and so this is in all versions of Oracle eBusiness Suite. So even if you just installed release 12.1.3, the latest and greatest version, Oracle E-Business Suite by default always stores the passwords as encrypted, not hashed. The hashing method is much more secure, and it's very simple to go through the FND user table and decrypt them. This hashing of passwords is optional, and it has to be enabled. If you're running 12.04 through 12.1.3, basically the patch is already installed, but you still have to go run and enable it. 11i and 12.04 and prior, you actually have to install a patch in order to enable the hashing. So it's a two-step process there. But once the patch is installed, and typically RUP 6 and above includes it, so a lot of most recent versions of eBusiness Suite that you probably are running, even 11i and R12, have the patch installed already, but it has to be enabled. It's not enabled by default. We talk to a lot of DBAs and say, oh no, we're running 12.1.3, Oracle will fix that. And I said, and yes, the answer is Oracle has fixed it, but it's not enabled. You actually have to go through and do a step to enable it. The biggest problem here is the encrypted application passwords are cloned to test and development. So that's as much the risk here is someone getting into production with the app's password and doing it. A bigger risk is from your test and development environments, because you're copying all those production passwords for all those end users down to test and development, and any of your developers, anyone access to those environments can actually decrypt them and then go into production. That's probably the biggest risk here. If hopefully you're limiting access to the app's password in production, you're limiting access to the FND user table if you have lots of apps to read accounts, because that becomes another issue. So basically, how do you fix this problem? That's kind of the biggest issue here. Is there is an issue. We see it at many of our clients when we do on-site security assessments. And so, what is the fix? There's a couple fixes. This isn't a real simple issue. It's very pervasive. It's very powerful to actually exploit. And so you have to do a couple different things beyond enabling the hashing. So the first one is enabling the hashing. So all the DBAs have to do is run FND CPAS user migrate. It's very well documented in my Oracle support notes. And basically that will convert all the passwords from being encrypted to being hashed. So they're kind of secure then, or more secure than they were before. There's another meta-link note that kind of shows you some of the SQL statements. I'll show you a SQL statement here that will also validate if the passwords are hashed or encrypted. One of the things even though you are running the hashing and the DBAs have run the user migrate, we still recommend when you clone, you change all application users' passwords. Because even though it's hashed, it's still possible to brute force the passwords. So when you're encrypting the passwords, all you have to do is decrypt them. As long as you can get the key, it's very easy to decrypt the passwords. When you're hashing, you can't really decrypt them. And the way you try to get back to the original value for a hash is it's called brute forcing. And what brute forcing is I'm just trying every possible combination. So if you're still copying the passwords down to test and development, someone can get hold of those hashes and take them offline and then run programs. And they're a pretty standard algorithm. It's SHA-1 that's used by the military and a lot of different organizations, very well respected. But I can still try millions of combinations. And with a typical brute forcing program, and you have the hashes, I can still try 1 million passwords per second against that. So it's very easy and trivial for me if anyone's got any kind of weaker default passwords to actually go through and try to break those passwords, even though they're protected pretty well with a hash, and it's much more secure than with the decryption option, but I can still try to brute force them. So when you're ever cloning, you should always be changing all the end user application passwords. So the second question always comes in then is, oh, we've changed the passwords and now our business analysts and everybody else can't get into test and development. What are we going to do? Well, the idea there is you enable the forgot password functionality, so everyone knows when they go into a test and development environment after it's been cloned is they just run the forgot password functionality and they can actually reset their password. And then the third thing that you need to do is make sure that you have the strong application password controls, the sign-on profile options for length, complexity, things like that, to basically make stronger passwords so it's much harder to brute force. If your password's welcome, that's going to be in a dictionary. I can probably get that password pretty quickly. But if it's welcome $1 sign, that's going to be much more difficult. So whenever possible, always make sure that you've got the strong password controls in place. So basically, what's the hashing doing? So now I've enabled the hashing, so my DBA went in, ran FND CPA user migrate, and has actually now changed all the encrypted passwords to hashed passwords. And so if we go back and look at the FND user table, there's the two columns, one where the key was the apps password, the other was the key with the username and password. Well, where the apps password was stored, that's no longer required, especially in R12. And so basically, they've actually taken that out, and it just has a standard value XG SHA-1 now. And then the encrypted user password is now the hash is stored in there. And you can tell the difference is, if you remember from the previous table, I saw ZH and ZG. Now they've changed it to XG and XH. It will be in that column. So the XG just indicates that it's a hashed value, and in this case it's uppercase or just non-case sensitive. If it's XH, then that would mean it's case sensitive password still being hashed in that value. So that's a very easy way. So it's very easy to check if the FND user table has been migrated from encrypted values to hash values. By just doing a simple query, you can see very clearly in this case that they are. So what are some of the requirements? What are some of the issues with installing the hash passwords? It's very easy to do. All you have to do is run FND CPA user migrate. Definitely always recommend backing up the FND user table before you do that, and then making sure that you drop that. We've seen that a number of cases, so people actually do run this. We're happy that they've actually taken all the passwords and hashed them, and then what we do is we look in and see that there's an FND user underscore backup table sitting there with the encrypted values. So if people have logged in recently, we can actually check out and get their passwords. So in order to run the FND user migrate, you have to basically be on at least 11.5.10 rep 6, 12.04, and 12.11. So most Oracle customers will have these versions. If you're behind on 11i, it's unsupported, but there were patches available for those earlier versions. But most 11i customers to be supported will be on at least rep 6. 12.0 customers need to be at least on 12.04, and all 12i is supported. But remember, this is not enabled by default, so these are just so you can actually have the ability to do it, and the DBA still always has to run the FND CPA user migrate to get the password hashes and replace the encrypted values. So if you want to validate, this is the statement that we typically use to validate the FND user table to see if the values have been migrated. So what you're doing is looking in the FND encrypted password value for the XG, XH, SHA-1 value, or in this case, some passwords will have invalid. So a number of the seeded accounts will have invalid. There's some other values there. So you ignore those. And then if you're running any kind of single sign-on, external would be the value in some of these columns. So you're just kind of ignoring that to see, okay, make sure that everyone's passwords have been migrated successfully to the hash values. Is there any downsides? Is there any issues with running the hash passwords? For R12, there's absolutely no downside. We've never seen an issue. No one has ever complained. There's a couple Metalink notes and bugs out there that have been long ago resolved. This is a very stable code. It works great. There's no reason not to do it in release 12. In 11i, there are many more issues because within the 11i environment, there's many more client-server programs. Almost all the client-server programs were completely replaced in R12. So instead of ADI, in R12, you're running Web ADI. But ADI is still pretty prevalent in a lot of 11i environments. It's still a client-server program. So when you do the hashes, all these programs have to be changed to support that new authentication mechanism. And so if you're running ADI, Discover, and really Discover is only the client-server version. If you move to OBIE, it's fine. No problems there. Configurator, some of these other programs that are all client-server based, they all have to be upgraded, and you have to go through and do the appropriate testing. So this is really the only downside is in the 11i environment, a lot of the older client-server programs won't work and have to be upgraded. And some versions don't even work. So you do have to do a little bit of testing and analysis before you implement this in 11i environment to make sure all your client server programs work appropriately and that there's versions that you can upgrade to make it work. So we always also get a question is, okay, I just don't want to even get involved with this decryption issue. This is too much. Then I've got hash values and things like that. Is there any other way around it? Well, you can actually implement single sign-on for Oracle E-Business Suite. So if you're running Oracle E-Business Suite and you've got Active Directory or another single sign-on solution internally, why even store the passwords in E-Business Suite? It does take a little bit of complexity. This isn't for the faint of heart type of architecture, but basically Oracle E-Business Suite fully supports single sign-on. So you implement Oracle Access Manager. It integrates with a number of external solutions like Microsoft's Active Directory. So if you're using Active Directory as a single sign-on company-wide directory and authentication solution, you can basically integrate Oracle E-Business Suite with that. So when people sign on, they actually sign on with their Active Directory account with that Active Directory password, and the password is no longer stored in the FND user table. What's stored there instead, it says just external, and it knows to go out for the external authentication. This becomes a little bit more problematic with iSupplier implementations and some of the other self-service implementations, because then they can use a mixed authentication. Some use local, the self-service accounts, and then they use Active Directory for the internal employees and things like that. So you kind of have to look at this, but it's a great solution to actually remove the passwords and the authentication from Oracle E-Business Suite. The authorizations in terms of responsibilities, functions, menus are all still stored in E-Business Suite and maintained there, but the authentication piece is actually removed. So if you disable somebody in Active Directory and you have single sign-on enabled, their account automatically is disabled in E-Business Suite because they can't sign in. And I put the Oracle MetaLink note there for the single sign-on. Very clearly documented, tells you exactly what you have to do. But again, you need to have separate servers, you have to implement Oracle Access Manager, there's licenses required and things like that. So it does take a little bit of effort, but it is definitely another solution to this issue. So that was basically the application password decryption issue. So just when you thought it was safe to get back in the water and we had this problem all resolved, there is another related issue. Oracle stores the application user's passwords in the FND user table. Well, they also store the database account passwords for all the Oracle E-Business Suite registered schemas. And what a registered schema is an account like GL. So every module within Oracle E-Business Suite has a database account. And that database account stores the data for that module. So general ledger's account is GL. Accounts payable is AP, fixed assets, FA. It goes on and on. There's about 250 of them. When Oracle does patching and things, when you run AD Patch and other tools, they actually have to sign into these accounts to actually go do maintenance and things. And so when you do that, you actually have to store the password somewhere, because you don't want the DBA having to type in 250 different passwords every time when they want to run a patch. So Oracle's solution is basically store those passwords in the FND Oracle user ID table, and basically they're encrypted. In this case, there is no hashing solution because they have to retrieve those passwords in order to log into those accounts. So when the DBA changes the GL account's password, they actually do it through the application, and it changes it both in the application table here, where it's stored, and also in the database. Well, this uses the exact same encryption as the application user accounts. So the same process that I just went through and showed you how I created a decrypt function and did all that, that's here too. And so basically now you can also decrypt all the database accounts. Again, the same scenario holds true, that I've got my disgruntled programmer developer, and so he's basically got access to his dev environment, and he has been able to get the access to the app's password. And again, this is now encrypted using the app's password, and now I can actually go into the FND Oracle user ID table and actually decrypt all the passwords. And when you're doing cloning, you're copying everything from production, and now I can actually now go into production with a database account and sign in as one of the database accounts like GL, AP, and now start doing behind-the-scenes SQL statements to do whatever I want. There's other controls you can put in place to fix this. One example would be managed SQL node access as part of e-business suite that limits what IP addresses can connect to the database. So anything you can do for a production environment to disable direct database connections except for by the DBAs and any authorized interfaces or anything is very helpful. Those type of solutions would also kind of mitigate this type of concern. The other thing you need to do is when you're going through and actually cloning from production and test and development, change all these passwords. And it's actually fairly easy. Oracle actually introduced, as part of the FND CPAS program, an option called All Oracle. And so you actually just put in one password. It'll actually change all the registered schema passwords in the FND Oracle user ID table at one time. Makes it very easy. There's not a significant risk that all passwords are the same. Theoretically, you could potentially do something if you were an encryption expert and had a pretty powerful computer to kind of correlate what that password was because it's encrypted over and over and over. But there's very minimal type of risk. So we'll kind of show you real quick. We got a few minutes here. And so I'll now kind of pop back out to SQL Developer. And so basically very similar to when I was doing the application passwords. So very similar. In this case, again, I still use my same decrypt function here that I was going to use before. And just putting in the apps password. Again, it's apps in this case. And the only thing I've really changed is I'm actually going against a different table now. Instead of going against FND user, I'm going to go against FND Oracle user ID. And let's execute this statement. And again, the encrypted value here is the key is the app's password is the encryption key. As you can see now, we haven't changed the passwords in this Vision demo environment, but all the passwords are really equal to the username. And so basically that's how easy it is. Now I can actually go into the GL account, and GL owns all the general ledger data and kind of do whatever I want in that environment. So again, very easy to do. This is not a complicated rocket science type of exercise. It's pretty straightforward. As long as you have access to the correct tables and know a slight amount of SQL, you can actually execute this very easily. So basically that's, again, the FND user. And the way you protect against this is whenever you're cloning, you should definitely be changing all the Oracle database account passwords. A lot of DBAs don't do this when they're cloning. I would say it's a small fraction, maybe 10 or 20% actually do this level of changes when they do clones. But when you're cloning, you should be changing all application passwords, all database passwords, and scrambling sensitive data and making some other changes. There's some other passwords that are stored within the business suite environment that it's recommended you change. So that's kind of a brief overview of the password decryption issues within Oracle Business Suite. The reason we did a separate webinar on this was that we believe it's such a significant issue. We see many developers having access to this data and able to do things. We do have an upcoming webinar on Tuesday, June 25th, kind of going through our series of kind of issues that people are really struggling with. The topic on June 25th is that when you can't apply security patches. A lot of cases are most organizations can't readily apply them within 30 days. They can't just get the security patches as part of the critical patch updates from Oracle and apply them immediately. And so what do? You just kind of wait and do nothing. What we'll try to do is go through and have some discussions about, okay, what are the common issues why people can't apply them? And there's a lot of Oracle customers out there who aren't applying them readily, and sometimes they're a year or 2 years behind. What are some of the mitigating controls you can put in place when you know you can't apply it due to version upgrade issues, other business requirements? And we'll talk about that. So that was an overview. We'll open it up to questions to see if we have any.
Thank you, Steve. We have a couple of questions here today. The first one, if I don't have access to the apps accounts that have read access to the FND user, is it possible to decrypt the passwords?
Yes, definitely. The example I showed is you had access to the apps user. That's the simplest, most straightforward way. But this is very standard code, so anybody can go into any Oracle Business Suite environment. And as long as you have that Java class, it's very easy to download from a patch, or you can get it a dozen different ways. and you can just load it into any database you want. And then if you loaded up the F&D user table into that database, you could definitely run it. You could write a Java program that was standalone that just called that Java class that went through and loaded up the Java class and then read from the file and could decrypt it there. So there's a dozen different ways to do it. There's really no limit to imagination on how many ways you can do this. The apps is definitely the easiest. So if you have access to a development environment, you get the app's password. It's trivial. It's maybe 2 or 3 more steps if you don't. But as long as you have read access to the F&D user table or the F&D Oracle user ID table and those encrypted password columns, you can definitely do this readily.
We had a couple of questions regarding one-way hash. I want to know if there were any problems or complications using that, and if you could include a review of known experiences.
For Release 12, I have never heard of anyone having a problem, and we recommend this basically to every client of ours. And we do a lot of security assessments per year, and I've never seen a problem on an R12 environment. 11i is just a different story because you've got the significant amount of client-server programs running. So if you're running any of these client-server programs, you actually have to go upgrade each of those because they do not work when you change it to the hashes. And what happens is they pop out of the woodwork all of a sudden. Like, oh no, no one's connecting, no one's doing that. We don't have a problem with that in our environment. And then all of a sudden you find out a month later, oh yeah, no, oh that guy over there in fixed assets runs the ADI and as part of fixed assets to load things up once a month, and he uses it one day, and oh, by the way, it's not working, we can't get any of our new assets in. You hear those kind of stories quite often. One of the things to do if you want to find that is actually enable database session auditing, and you can actually get a list of who's actually connecting to the database, and you can actually do some sorts on that pretty quickly, run that for a month or two, and you'll actually know if any of these programs are connecting, because within that tells you the program name, and you just sort by program name. And 2 or 3 months of session auditing will very clearly tell you what programs are being used. And if you just go through that list to figure out where the problems are, it's pretty easy to resolve. But you do have to upgrade all these, and there's patches for each one, and that's the challenge in the 11i environment. Some people run a bunch of these, some people don't run any of them. ADI is typically the biggest one, and then maybe Discover behind that, and then maybe Configurator. And then occasionally you'll see some of the other programs running. It just depends on your environment. But except for that, no application issues. It's only the client-server programs that I've ever seen an issue with.
Another question. Is it possible to insert your own hash values from known passwords into the F&D user table and hash into the account?
Yes, that's actually a very easy, trivial thing to do. When you go through some of the actual standard Oracle code, some of the recommendations they make on cloning on how to fix some of these issues, they actually do direct table updates to change these values. There's no salting based on database environment. So as long as I basically know what the app's password is and the hash, I can just I can generate the hash, or I can actually go through and generate the encrypted value. But the key is I need to know what the app's password is. And if I know the app's password, you're pretty far along the game there. So I typically wouldn't think that's a great risk, because if you got the app's password, you can do whatever you want anyways. But you do need to know the app's password in order to create the user passwords, or also to create the hashes. The hashes are encrypted after they're hashed, so you do need to know the app's password in order to get to the hashes too, in order to generate a hash. So if you know the app's password, you already have access to the environment. But yes, it is very easy to do for a DBA to directly replace. And some of the standard Oracle code does that. If you want to kind of reset people's passwords, you can just run an update statement and set the password.
Yeah, the one last question asking you whether CPE credits we issued for the webinar, and I'm sorry to say no, we neglected to set that up for this one. So, and I believe that's the end of the questions. So we appreciate everybody being with us today, and be sure to stay tuned for our session in this next month. Again, thank you everybody, and have a great rest of the day.